Hello pre-calc students, this is Mr. Lal here doing a video solution key for your vectors homework so that you can check your work and understand the process on how to get the right answer. Alright, a pilot directs a plane 40 degrees south of west at a speed of 430 miles per hour. There's a wind blowing at 50 miles per hour due south. Find the resulting direction and speed of the plane. So first we need to find the magnitude and the direction of the first vector. So first we need to convert our degrees. So 40 degrees south of west. If you are facing west and you move 40 degrees south, right, that's going to be 180 plus 40. So that's going to be 180 plus 40, which is going to be equal to 220 degrees. So our magnitude 1, we have our magnitude 1, which is equal to 430 miles per hour. And our theta 1 is going to be equal to 220 degrees. Then we have our second magnitude, which is our magnitude 2, M2, is equal to 50, and I'm sorry, this is 430 miles per hour. And magnitude 2 is going to be 50 miles per hour. And our theta 2 is going to be equal to due south. Now south is going to be equal to 270 degrees. So theta 2 is equal to 270 degrees. Alright, so I have our M1, our theta 1, our M2, our theta 2. So now we need to find the horizontal and vertical components. So we have our horizontal components, which are going to be 430 times the cosine of 220 degrees plus 50 times the cosine of 270 degrees. This is our horizontal component. Our vertical component is going to be 430 times the sine of 220 degrees plus 50 times the sine of 270 degrees. So we do our work, we get our calculator, so we're going to evaluate this term in our calculator, and we're going to evaluate this term in our calculator. So let's plug it, turn on the calculator, mode, go to degree mode, and then I'm going to plug it in. 430 times the cosine of 220 plus 50 times the cosine of 270. So that's going to be negative 329.39. So that's our horizontal component. Our horizontal component is negative 329.39. The horizontal component is negative 329.39. And our vertical component is going to be, let's calculate things in the calculator again. 430 times the sine of 220 plus 50 times the sine of 270. So that's going to be negative 326.39. Negative 326.39. Now that we have found our horizontal and vertical components, we now need to find the magnitude and direction of the new vector. So this is our resultant vector in component form. So we need to find it. First we need to find the direction and the speed. And the speed is the magnitude of our resultant vector. So our magnitude is going to be equal to the square root of negative 329.39 squared plus negative 326.39 squared. And this comes from the Pythagorean theorem. So to find our value, find the square root of negative 329.39 squared plus negative 326.39 squared. So that should give us a magnitude equal to 463.711. So our magnitude is equal to 463.71 miles per hour, which is the speed of the plane. All right, to find our direction, we must realize that our direction is going to be equal to the inverse tangent of y over x. That's going to be the inverse tangent of negative 326.39 over negative 329.39. And so let's plug into our calculator, degree mode. So our calc output, so when we plug this into the calculator, we find the inverse tangent of negative 326.39 over negative 329.39. That should give us an angle of 44.73. So calculator output is 44.73 degrees, but that is not our answer. And the reason why that's not our answer is that because our x value is negative and our y value is negative. So because when our x value is negative and our y value is negative, that's going to put us in quadrant 3. Hopefully you should know that 44.73 is in quadrant 1. So what we do is that even though 44.73 is a reference angle, our actual angle is going to be this angle right here in quadrant 3. And that's going to be 180 plus our reference angle. So because this value is negative, because our x value is negative, so because our horizontal component is negative, therefore our horizontal component is negative. Therefore, theta is going to be equal to 180 plus 44.73. Remember, 44.73 was our calculator output. That was our calc output. So 108, so 44.73 plus 180 is equal to 224.73. So that's equal to our actual angle, our direction is going to be equal to 224.73, which is degrees, which is our direction. So let's box it up. So our answers are, our magnitude is 463.71 and our direction is 224.73 degrees. All right, I'm moving on to problem 2. What is the magnitude and direction of the resultant of a 105 Newton force, a direction of 15 degrees east and south, and 110 Newton force at an angle of 25 degrees north of east? So I'm going to be a little bit less methodical for problem number 2. Magnitude 1 is going to be equal to 105, and theta 1 is going to be equal to 15 degrees east of south. That's going to be 270 plus 15, which is going to be 285. Magnitude 2 is going to be equal to 110. And theta 2, remember these units are newtons. And theta 2 is going to be equal to 25 degrees north of east, so it's going to be 25 degrees. So we need to find a resultant vector in component form. So our resultant vector is going to be 105 times the cosine of 285 plus 110 times the cosine of 25, and that's our horizontal component. Our vertical component is 105 times the sine of 285 plus 110 times the times the sine of 25. So this is going to be, plug things in, 105 times the cosine of 285 plus 110 times the cosine of 25. That's going to be 126.86. That's our horizontal component. So our horizontal component is 126.86. Now, vertical component is going to be 105 times the sine of 285 plus 110 times the sine of 25. So that's going to be negative 54.93. And by the way, this puts us in quadrant 4. When the x is positive and y is negative, this puts us in quadrant 4. In quadrant 4, we our theta does not change from calculator output. All right, so that's true for quadrant 4, and that's also true for quadrant 1. This is just a side note. If you're in quadrant 2 or quadrant 3, your direction is going to be equal to 180 plus calculator output. So remember, if Your calculator output is negative. 180 plus a negative number is 180 minus a negative number. All right. Okay. So let's find the magnitude. The magnitude is going to be equal to 126.86 minus 54.93. So it's going to be the square root of 126.86 squared plus negative 54.93 squared. And so we take the square root function of 126.86 squared plus negative 54.93 squared. That's going to give us a value of 138.24. So our magnitude is going to be equal to 138.24 newtons. All right. On our direction, which is theta, is going to be equal to the inverse tangent of y over x, which is the inverse tangent of negative 54.93 over 126.86. So we find the inverse tangent of negative 54.93 divided by 126.86. That's going to be negative 23.41. So our theta is going to be equal to negative 23.41. So theta is going to be equal to negative 23.41. And this is a correct answer, but we can also represent this as theta is equal to 360 minus 23.41. So 360 minus 23.41 is going to be equal to 336.59. So theta is equal to 336.59. So theta is equal to 336.59 degrees. All right. So that is our value, 336.59. All right, that's our value. Let's go to problem number 3. A yacht is cruising 20 knots at a bearing of 185 when a 15-knot wind starts blowing at a bearing of 290. Find the direction and speed of the boat. So here we don't have to do any conversions. We can just go straight to the fact that, and hopefully we're getting more used to this now, we're going to have our horizontal component is going to be 20 times the cosine of 185 plus 15 times the cosine of 290, comma, 20 times the sine of 185 plus 15 times the sine of 290. So that's our component, and then we plug this into the calculator. 20 times the cosine of 185 plus 15 times the cosine of 290. It's going to be equal to negative 14.79. So it's going to be equal to negative 14.79, comma, 20 times the sine of 185 plus 15 times the sine of 290. Negative 15.83. Negative 14.79, negative 15.84. Alright, that's the horizontal component. This is the vertical component. Alright, so we're in quadrant 4. No, we're in quadrant 3. So when we are in quadrant 3, theta is going to be equal to 180 plus our calculator output. It's our calculator output. So because of that, our magnitude is going to be equal to square root of negative 14.79 squared plus negative 15.84 squared. So we're going to have a magnitude of the square root of negative 14.79 squared plus the value of negative 15.84 squared. I need to do this again. The square root of negative 14.79 close parentheses, square it, plus the open parentheses, negative 15.84 close parentheses, square it. Alright. So that's going to give us a magnitude of 21.67. Alright, was very careful with those calculator inputs. So our magnitude, so the magnitude, so this is not going to be M1, this is going to be our magnitude. So our magnitude is going to be equal to 21.67 knots, which is the speed of the boat. All right. Increase the thickness or decrease the thickness. Our direction, so theta is equal to the inverse tangent of negative 15.84 over negative 14.79. So theta is equal to the inverse tangent of negative 15.84 over negative 14.79, which is going to be 46.96. So theta is equal to 46.96 degrees. But remember, we're in quadrant 3, so to find our reference angle in quadrant 3, we have to do 180 plus our calculator output. So we are going to do 46.96 plus 180, which is going to be 226. So remember, this is just our calculator output. Our actual angle is going to be equal to 226.96 degrees, which is the direction of the boat. All right, 2 more problems. Nancy and Harry are sliding a stone statue. Now, I believe I'm going to do this one real as I'm going to give you guys the answers, but I'm not going to be explanatory because I've already done this in class. All right. Theta 1 is equal to 60 degrees west of south, so that's 210. Theta 2 is equal to 40 degrees north of D, that's 40. So 120 Newton. And 2 is equal to 180 newtons. So plug this into your calculator. We're going to have 120 times the cosine of 210 plus 180 times the cosine of 40. So our horizontal component is going to be 33.96. And then our vertical component is going to be 120 times the sine of 210. And our second value is going to be 180 times the sine of 40, which is going to be 55.7. So 33.96, 55.7. We're in quadrant 1, so calculator output is equal to theta. Our magnitude is going to be the square root of 33.96 squared plus 55.7 squared. That was 65.23. So actually, we're fine here. It's just asking for the magnitude of the horizontal force exerted on the statue, right? And the horizontal force on the statue is going to be 33.96. That is the horizontal component of the resultant vector and therefore the horizontal force on the statue, and therefore all of that. Cool. All right, one more problem. So the sled dogs have gone mad. Okay, the sled is being pulled in 4 directions, and no one knows where the sled will wind up. You need help. Dog 1 is pulling due east at 15 degrees north, or 15 newtons. Okay, so M1 is equal to 15 newtons. Theta 1 is equal to due east 0 degrees. M2 is going to be equal to 12 newtons. And then 40 degrees south of east is going to be 360 minus 40, which is going to be 320. Theta 2 is equal to 320. M3 is going to be equal to 13 newtons. 34 degrees north of west is going to be 180 minus 34, which is going to be 150 minus 4, which is going to be 146. So theta 3 is equal to 146. And degrees, and M4 is equal to 18 newtons. theta is 12 degrees north of west, which is going to be 180 minus 12, which is 170, which is 168. Which is going to be 168 degrees. Okay, so let's plug this into our calculator. So our horizontal component is going to be 15 times the cosine of 0 plus 12 times the cosine of 320 plus 13 times the cosine of 146 plus 18 times the cosine of 168 degrees. And our vertical component is going to be equal to 15 times the sine of 0 degrees plus 12 times the sine of 320 degrees plus 13 times the sine of 146 degrees plus 18 times the sine of 168 degrees. So let's find our horizontal component. 15 times the cosine of 0 plus 12 times the cosine of 320 plus 13 times the cosine of 146 plus 18 times the cosine of 168. So our horizontal component is negative 4.19. Negative 4.19. And our vertical component is going to be 15 times the sine of 0 plus 125 times the sine of 320 plus 13 times the sine of 146 plus 18 times the sine of 168. So that's going to have a component of negative 69.33. Alright, so now we need to find the magnitude and the direction. So this is in quadrant 3. In quadrant 3, for theta, we add 180 to our calc output. 180 to our calc output. But let's do the magnitude first. The magnitude is going to be the square root of negative 4.19 squared plus negative 69.33 squared, which is going to be 69.45 squared. So our magnitude is going to be equal to going to be equal to 69.46 newtons. And our direction, our direction is going to be equal to the find the inverse tangent of negative 69.33 over negative 4.19. So we're going to find the inverse tangent of negative 69.33 divided by negative 4.19. There's going to be 86.54. So theta is equal to, our calculator output is equal to 86.54 degrees. So to find theta, theta is equal to 180 plus 86.54 degrees, because this is quadrant 3. Both values are negative. So we add this to 180. And our direction is going to be 266.54 degrees. So our direction, theta, is equal to 266.54 degrees, which is the direction of the sled. All right, that's the video. That's the magnitude of the direct and the direction. So excellent. Have a great night.